Alright, hey y'all, it's some Summers. With your notes today, this is the second day of our third unit. Today is September 17th, I do believe. Yes, it is September 17th. And today we are looking at layers of the Earth. Yesterday, just a quick refresher, we talked about continental drift and how that fellow Alfred Wegener knew that the continents had moved around. But you'll recall that his biggest folly, his biggest problem that he had, was that he couldn't tell how the continents moved around. So we are going to be looking into that next week. But in order to do so, you have to understand the layers of the Earth. So that's what today is about. What are the layers of the Earth like, and how do we know that they're actually, there? All right. So the Earth, if we were to cut it in half, I'm sure you probably did this as a kid. You were like, I'm gonna dig a hole to the other side of the world. Whee! As little kids, we don't realize the ground beneath us doesn't stay the same all the way through. But what we have found is that the Earth is divided into these different layers. Okay? So the interior of the Earth consists of three major zones, all right? And within these zones, there are smaller layers. So we're going to look at the zones first. The zones are the crust, the mantle, and the core. And this is working our way from the outside, is the crust, and then we're getting deeper and deeper towards the center of the Earth, all right? So how do we define the crust? What is it like? What's it made out of? All that good stuff. The crust is the part that you're familiar with. So you live on the Earth's crust. It is the thin, rocky outermost layer. So it is the side of the Earth that's on the outside, that's exposed to the atmosphere, that's exposed to the rest of the environment. All right? And there's two types of crust. There's continental and oceanic. And you can think of continental and oceanic almost like pizza crust. Continental crust is really, really thick, kind of like Chicago-style pizza is, like deep dish pizza. While oceanic crust is relatively thin. It is like New York-style pizza. All right, and when we get to plate boundaries tomorrow, you will have to know the difference. All right, so continental is thick, oceanic is thin. And we have a diagram like this. This is why, y'all, oceanic crust is under the oceans. If oceanic crust were thicker than continental crust, oceans would be above us, and that wouldn't make any sense. All right, so continental crust is thicker. Oceanic crust is thinner. All right, quick true-false check-in. True or false? Oh, let me click that. Click. Click. There we go. Can the Earth's crust be categorized in two ways? Oceanic, continental. That is true. Is continental crust thinner than oceanic crust? That is false. All right, you would have to switch either these words, oceanic crust is thinner, or you could change this word to thicker. Continental crust is thicker than oceanic crust. And lastly, the crust is the thick, rocky, innermost layer of the Earth. That's false, because the crust is thin and it's outside. It's the outer layer, okay? You can almost think of the crust as the skin of an apple. All right, it's just the covering. There's a lot more stuff underneath. All right, so after we see, we live on the crust, if we were to go down throughout the Earth, the next zone we would approach is the mantle. The mantle takes up 82% of the Earth's volume. So the mantle is the biggest chunk. It's what the most of the interior is made out of. The mantle is solid, okay? But it's not solid like rocks that we think about, like on the surface of Earth. Sometimes this solid material can act like a liquid in that it can move around. It's very plasticky. It can bend without breaking. That's what we mean by plastic. It is composed of mostly silicone and oxygen, and it extends to this depth, 2,890 kilometers. I don't necessarily need you to remember those details, but I do want you to remember that it's the majority of the volume and that it's solid, but it's flexible. All right? So the mantle can move around by a process called convection. So that's all I need you to write right now. Convection is how the mantle can move around. That's going to be very important when we get to plate tectonics. All right, so just keep that on the back burner, okay? I won't explain convection today. We'll get there next week. All right, so we have the crust, the thin, rocky outermost layer that can be either oceanic or continental. Then we have our really big mantle that is still solid, but it's like a flexible solid. It can bend and sort of move around. All right, so let's true or false this real fast. I'm sorry, I forgot I had this slide. All right, true or false? The mantle is made up of a material that can act like a solid and a liquid. That is true, because the mantle is flexible. And the mantle is the smallest or thinnest layer of Earth. You know that's false, because the crust is the thinnest layer. The mantle is the largest layer. All right, so we can make that statement true by changing one of two things. All right, so we have the crust and the mantle. Our final zone is the core. And we are going to talk about the difference between outer and inner here in just a second. The core is a sphere that is made out of iron and nickel. Iron and nickel are both heavy metals. And you remember from the beginning of the year, we talked about density and how things that are more dense want to sink. Iron is more dense than oxygen and silicone, which is what the mantle is made out of. That's why the core is mostly iron. All the really dense stuff sank to the middle of the Earth. All right, the core is really, really hot. Temperatures from 5 to 7,000 degrees. Again, that's going to be important for plate tectonics. So let's look at, so that's our three main zones. The crust, the thin crust, the big mantle, that's solid but still flexible, and then our cores, which are metallic and really, really hot. There's another picture, a nice little cut. So if you were to cut the Earth in half this way, this is what you would see. Now what I want us to do is I want us to go back to the crust of the Earth. We're going to go back to the outside, and we're going to look at how the layers are defined, okay? So the crust, mantle, and core are the three zones. Where are the layers at? All right? And there's 5 of them. Take a minute to write this down. Pause the video if you need. All right? The first layer is the lithosphere. All right? Litho means stone. So this is the crust and the upper part of the mantle that's solid. All right, so this is brittle. It breaks up really easily. We live on it. Below the lithosphere is the asthenosphere. All right, the asthenosphere is a part of the mantle. And because it's warmer, the rocks can move around, sort of like hot wax. Okay, so imagine you take like a candle, you burn it, or like a Scentsy or whatever, and the wax is starting, it's not quite all liquid, but it's flexible. All right. Below the asthenosphere is the lower mantle, or the mesosphere. We're going to use mesosphere in another aspect, so don't get super hung up on this term, because you're going to see it later on this year regarding something else. All right. But the mesosphere, or the lower mantle, is the bottom of the mantle. All right. It's rigid, it's solid still, because remember, the mantle is solid, but it's still hot enough that the rocks can move around and flow. All right, they're flexible, kind of like plastic. All right, so that encompasses the crust as well as the mantle. Now we have our 2 layers of the core. We have the outer and inner core. Okay, the outer core surrounds the inner core. Okay, so it's in between the mantle and the inner core. And the outer core is liquid. This is the only layer of the Earth that's liquid. It's like you could put it in a glass. I mean, you couldn't because it's really hot, but you get what I'm saying. The outer core is important to us because it generates our magnetic field. Okay, so if you remember from astronomy, all right, we talked about the sun. The sun actually produces radiation that we don't necessarily want to receive here on Earth. All right, the magnetic field acts like a barrier to that. It shields us from radiation from outer space. All right, and so because the outer core is liquid, it's a metal and it's spinning with the Earth's rotation. That's how that magnetic field comes to be. All right, the inner core is a sphere of solid iron. It's 100% solid. So you might be like, well, how is this liquid? You know, this outer core is hot enough to be a liquid. Why isn't the inner core liquid? It's because there's so much gravity and so much pressure. The entire weight of the world is pressing down on the inner core, that those little iron molecules, even though they're really hot and they don't want to be near one another, they get stuck together. And that's why it stays solid. Okay? So we have, just to reiterate, we have our crust, mantle, and core. Those are our three zones. If we look at our crust, we have continental over here that's thicker, and oceanic, which is over here, that's thinner. All right, but if we look at the layers, we have the lithosphere, which is the crust and the upper mantle, right here. The asthenosphere, which is this orange part, that's the part that can move around like wax, or like silly putty or jello. Some people describe it as that. Then we have our lower mantle here in the light orange and yellow. We have our liquid outer core that makes our magnetic field, and our solid inner core that's solid because of pressure. All right, let's do another true false based on the layers. The lithosphere is composed of the crust and the upper solid portion of the mantle. That is true. That is what the lithosphere is. It's the solid brittle part. The core is composed of two parts. That is also true. All right, the outer core is liquid. The inner core is solid. Oh, and looky there, I just answered your question. The inner core is liquid and the outer core is solid? Nope, flip those around. Outer core is liquid, inner core is solid. Okay, the inner is solid again because of pressure. So we know, based on data, that temperature and pressure increases as you go down throughout the layers. All right, so over here on the crust, it's like normal temperature, like 0 degrees Celsius, that's like 30 degrees Fahrenheit. But as you get into the mantle and the core, it's thousands and thousands of degrees Celsius. So the question is, well, how do we know this? Because obviously we've never actually been to the inner core. We've actually never been to the outer core, or the mantle for that matter. People have never been able to get all the way through the crust. So how do you know that these things are actually there? And the answer is, we look at how things move through the earth. We look at these things called seismic waves. So a seismic wave is a vibration that goes through the earth, and it's caused by an earthquake. And we're going to get to this later on next week, the difference between P waves and S waves. S waves do not have the ability to travel through liquids. So when we look at an earthquake happening here, on the other side of the world, the P waves are able to travel through, but the S waves can't. So that's how we know there's some liquid here in the center. I don't necessarily need you to write any of this down. I don't expect you to memorize the density of Earth. Just know that temperature and pressure both increase as you go down into the Earth's surface. After 20 meters below the surface, all right, even if, regardless of where you were, you could be in Antarctica or you could be on the equator. If you were to dig a hole 20 meters down, the temperature would be the same everywhere. And then as you continue to go further into the earth, it would get hotter. All right, so last true or false, and that'll wrap these notes up. Temperature and pressure decrease as you go further down into the layers of the earth. Well, that is obviously false because we said it increases. It gets hotter and more pressure as you go down into the earth. Seismic waves are vibrations that travel through the earth. They are caused by earthquakes. That is true. And seismic waves are how we can tell what the inside of the earth is made out of. Right? So those are notes today. If you need to, you can go look at the note summary that is on Canvas, and then you have an assignment that has you looking at some diagrams of the layers of the earth.